Video on running uphill and explaining ground reaction forces. So we have a diagram of a runner going uphill, and this is going to look into different directions. So we're looking at a positive velocity, meaning the runner is going uphill. They are accelerating. So let's first look into our forces. So let's kind of zoom in here a little bit. Okay, let's first start with kind of graphing out our forces. So we have this force kind of going upward. We have our gravity kind of going downward. Let me actually fix that. So let's kind of redo that. Okay. So we have our gravity. Give me 1 second to fix this. So we have our parallel force right here. So this is our parallel force. We have a perpendicular force. So this is going to go this way. So perpendicular, so it's gonna be kind of like here. Let me first try and do that again. Sorry. Okay. So we have our perpendicular force going this way. So perpendicular forces. There we go. And then we have our gravitational force, right? So gravitational force. Let's make sure we understand that. Kind of just like fix this little box right here. Okay. So we have our gravity, we have our parallel force, and we have our perpendicular force. So let's also add, and I'm going to use a green for this. So we have our gravitational force that's kind of pulling us down, and this is essentially when the runner's weight is acting directly down onto the slope. So that's basically the center of mass. So center of mass, right? And essentially that's going to go into the ground right here. And then we have our proportion force. So our proportion force is acting on the parallel. It's acting on the parallel, right? Meaning it is gonna go forward. So we're gonna kind of do it here, right here. So our proportion force is gonna be right here. So F. Let's do prop, right? So that's going to act on to our foot. So this is when our foot makes direct contact with the ground, and then once this leg kind of swings over, this is going to kind of bend, and then once that leg swings over and hits right here, the runner is going to push off against that ground, and thus entering that propulsion. I apologize. My pronunciation is kind of bad sometimes. But then we also have our drag resistance. So drag resistance is also acting on that parallel, and this is when the air resistance is going to hit the runner. So we have a stick figure, but imagine that runner has a bit of loose clothing. It could be loose, it could be tight, but because we're going uphill, there will also be that proportion for that drag force. So it's a resistance force pushing the runner back. So that'll be FD. So that is our drag force. Because the runner is upright and not in an aerodynamic position, the air is going to push against the torso, If the runner was in an aerodynamic position, you would think you would have the head kind of forward. It's going to be bent forward this way, right? And so then the air resistance will hit the head and kind of go over. But the runner is in a comfortable position, so they are upright. And so we would also mention the brake forcing. So this is when the backward directed component of the ground reaction force occurs after the initial foot contact. So this will hit right here. This is our initial contact. So let me actually fix this right here so we can get that a bit better. So you have your ground reaction force right here. So we have the ground reaction force. So let's kind of do ground reaction force. And this is essentially the braking force. So our foot hits the ground, and because isn't that because once it hits the ground, our runner is acting onto that ground and pushing onto that ground, and the ground in reaction to that, as Newton's third law of motion, is causing a braking force. So kind of push, let's do it like this, right? And then meaning that forward directed component of the ground reaction force is going to drive that runner upwards. So we're going to have the proportion acting on the back of the leg. So let's try this, and then proportion will work right here at the back of the leg. And that is because once that leg swings over, this leg is going to push off the ground and then accelerate the runner. And then this is going to be our equation. So the force of proportion minus the force of brake minus the force of gravity minus the force of drag. Oh, this should equal. That will equal the mass times acceleration. I guess my keyboard just didn't want to sticky. I don't know what I just said. I apologize. I was put shift. Oh, that's what I did. I accidentally shift, then messed it up. But it's supposed to be equal, not plus. And so how does this thus help explain our next thing? Well, ground reaction forces, as I mentioned earlier, is essentially an application of Newton's third law of motion. So once that runner pushes against the ground will act back and push the runner. So, and it's also used as a parameter in biomechanics to study human movement and gait patterns. And these researchers will use like a multi-axis force platform to study these different directions, such as the vertical, the interior posterior, and the medial lateral directions. And you will have that in different ways for runners. So you have your vertical, you have your horizontal, and then your medial lateral. But we will be looking specifically at the horizontal to look at how it will change a velocity, how the runner's velocity will change in a specific phase of gait. So what is Newton's third law? Well, Newton's third law states with every action there is a reaction, meaning when someone acts on something, that object will react. And in running, this will mean the runner makes point of contact with the ground. They will apply a force onto that earth, and then the earth will respond back by pushing against the runner. And this reaction will either help them accelerate, decelerate, or even maintain momentum. And in the horizontal direction, which is the interior posterior, a runner will go through many gait phases, and it's not really many, but like but we'll focus more on the stance phase rather than the other two phases. And this is typically split into two subphases, and it starts with the first point of contact made against the ground until the foot leaves the ground again. So this is basically when your runner, I'm gonna go ahead and draw this out for you guys. Give me 1 second. Give me 1 second. There we go. So let's use this. Let's use a blue. So you have your runner, right? Is a little stick figure. Do 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 do. So when you're running, when you're in the flight motion of running, your both feet will be off the ground at one point in time. I apologize. I'm not the best drawer when I'm on my computer. So say about there, and then let's put our ground right here. Oh, that is not the best. Let me try that again. That is not working out for me. There we go. That's the best I can get it, right? So let's try and redraw our little person. Kinda go this way and this way. So you see this is our flight phase. We're going to have the runner start into the stance phase. So we're going to hit, so this foot is going to go and make contact with the ground, and then you still have this foot in motion and flight, correct? So can you see how that makes contact with the ground? The ground will then push against the runner, and this part of the phase will cause a slight deceleration. This will cause a deceleration because the runner is pushing against it, and it's a forward momentum, meaning the ground is going to oppose that forward momentum. It's going to push against it. And so your runner is going to, oh no. My apologies. I don't know what's going on with my computer. Well, I kind of do. It's old. So your runner is going to hit a little phase right here where the... oh no. Where essentially the knee will kind of bend on the ground. It's going to start bending, correct? And then it's going to, oh, well, there goes my thing. Oh, okay, try this again. It's going to bend, so basically think of it as a spring. Let's kind of think of it as a spring, so it's going to start bending a bit, and it's getting ready for that swing phase of the leg. So this leg will swing over, and essentially this is where the center of mass is crossing over that interior foot because of the momentum is still going. And then you're going to hit the proportion phase right here. I don't know what's going on with my figure. There you go. I apologize. My figure is not the best, but it's okay. We're working with it, right? And then we're going to see that proportion. So the foot kind of extends, and then we have our other foot back up. Okay, beautiful, right? So let's try this again. So force of gravity. Okay, this is our first point of contact. Okay, and then force of the ground reaction force. Okay, so this right here is a flight path, right? And then over here is another flight. So it's kind of, there you go. So meaning this is our stance phase. Okay. So essentially, the changes in velocity will begin at the stance phase when the foot makes contact with the ground first. And this is due to that ground opposing that forward momentum, and it will initiate a deceleration. However, because there is a forward momentum, the runner's center of mass is going to cross over that interior foot. And when it does that, the runner is starting to push against the ground, and because it's pushing back on that ground, the ground is pushing the runner forward, thus triggering that ground reaction force to accelerate that runner. And this is how the velocity tends to change between the stances of gait. And so we're at a flight phase, so we're already running, we're good, we're maintaining that momentum, and then we hit the ground, and then the ground will push against that forward momentum, though we keep that forward momentum going, so our center of mass goes over that interior foot, thus having the runner push back against that ground, and the ground reacts to that and pushes the runner forward, and then we resume our flight. Okay. Oh, thank you for watching this video.